Hi all, I wanted to give you another example of how to connect a function with the graph of the first derivative of that function and the second derivative. So I'm going to do this in kind of a couple of steps here. So first, here's my graph, and I'm told that the graph is the graph of f prime. It's the derivative of f. So I'm going to be asked for a couple of things. So the first one, let's say that they ask, where does f have local mins and maxes? So I'm asked for local mins and maxes of f. I know those are the zeros of f prime. So I look and I see one here, here, and here. Okay. Now the min is where f prime goes from negative, f is decreasing, to positive. So I'm not writing this in full sentences, but this is more just to give you an example. So your min is where f prime goes from negative to positive. So at -4, it goes from negative to positive. So at x equals 4, f has a min. We cannot say the y-coordinate because we don't have enough information to give the y-coordinate of f. Now I'm going to look at the next zero. At 1, it's positive to positive, which is not the function changing sign. So the function is consistently increasing around x equals 1. So that's neither a min or a max. And then at 3, it's going from positive to negative, so it must be a max. So I have a max at x equals 3 because f prime is changing from positive to negative. Okay. Okay, so now let's look. It's still f prime, but we want to find where f has where f changes concavity. So we want to look for the points of inflection. Okay, so we want points of inflection. Okay, which is where f prime changes from increasing to decreasing. And this is where you have your local mins and maxes. So you have a local max here. Let's look at this point too, here and here. Now remember, the corners, the derivative doesn't exist, but that doesn't mean, just because the derivative doesn't exist, it doesn't mean that f doesn't have changes in concavity there. So for instance, at x equals -3, right, your curve is changing, from increasing to decreasing. So that's a point of inflection. At 0, it's going from decreasing, but then it stays decreasing on the other side. So it's not a point of inflection. At 1, it changes from decreasing to increasing. And at 2, it's changing from increasing to decreasing. So our points of inflection of f are at x equals -3, 1, and 2, because f prime changes from increasing to decreasing, or vice versa. Okay, again, we're not worried about where the derivative doesn't exist, right? Because the second derivative may not exist, but that's it doesn't change the fact that f prime is changing from increasing to decreasing at those points, and therefore f is going to have points of inflection. All right, so now I'm going to say, all right, it's still the graph of f prime, but we want where f is increasing. Just where it's increasing, not decreasing. F is going to be increasing when f prime is positive. F is decreasing when f prime is negative. We're only going to look for the increasing for right now. So f prime is positive where f prime is above the x-axis. So all through here. Okay, and all through here, it's also positive. So I could just say from -4 to 3. Okay. Now, what if you're also asked for where f, so f is concave up. F is concave up when f prime is increasing. So when f prime has a positive slope. So I'm going to look now, where does f prime have a positive slope? And it has a positive slope all through here. It's increasing. And here. And that's it. So f is going to be concave up from -5 to -3 and from 1 to 2. Okay, so now we're looking at the same graph, but now we're told to consider this graph the second derivative. So this graph is now the second derivative of f. So how is this going to change things? All right, so let's go back to that question that said, where does f have points of inflection? So on our second derivative, if f has points of inflection, f double prime has zeros and f double prime changes sign. So f double prime here has zeros at -4, 1, and 3, but again, it's not changing sign at 1, right? So 1 is not going to be a point of inflection. So f is going to have points of inflection at x equals -4 and 3 only. Again, I can't find the y coordinates of these points. Okay, the 0 would be the y coordinate of those points of f double prime, not of f. So I cannot say -4, 0 or 3, 0. I can only give the x coordinates of those points of inflection. Okay, so still the graph of f double prime. Now let's try to find where f is concave down. So f is going to be concave down when f double prime is negative. Okay, and remember, another way of saying negative is below the x-axis. So I know f double prime is going to be concave down whenever this graph is below the x-axis, which are on these intervals. -5 to -4 and 3 to 4.